There's a question involving kinematics. We are given a velocity statement. We're asked to find when the particle is stationary. We're asked to calculate its acceleration and its distance. So we've got velocity and we need to find acceleration, and also given velocity we're asked to calculate displacement, or the distance. So remember, as I go from velocity to acceleration, we differentiate because we differentiate down. And as I go from velocity to displacement, we anti-differentiate. So let's look at the first question, A. When is the particle stationary? Well, anything is stationary when it has no velocity. In other words, when the velocity is 0. So I've got an equation, v equals 3t squared minus 6. What I'm going to do is I'm going to set that equal to 0. And then we solve for t. So if we do that, we add 6 to both sides. It's equal to 3t squared. We divide both sides by 3. And therefore t squared is equal to 2. And therefore I take the square root of 2, so that becomes plus or minus the square root of 2. Now remember, the particle starts from point P, so the situation is really from time equals 0, so we're not going to include the negative therefore, so t is equal to 1.41 seconds, which is the square root of 2. So that's when the velocity, that's when the particle is stationary, after 1.41 seconds. So let's look at B. We want to calculate the acceleration. So I'm going to write velocity down is equal to 3t squared minus 6. And we differentiate to get the acceleration. So that becomes 6t. And we want to know what the acceleration is after 3 seconds. So we substitute in 3. 6 times 3 equals 18. I'm doing in centimetres here per second, so that's centimetres per second squared. So there we are, we've got the answer for B. So C now is the distance. So again, we start with the velocity equation, 3t squared minus 6. But this time to get S, we anti-differentiate. So we get 3t to the power of 3. We add 1 to the power, then divide by that power, minus 6t plus c. These 3's cancel out, and therefore I get t cubed minus 6t plus c. So what I want is I want some information in regard to the distance and the time of the particle at a particular point, and all we know that is that starts from point P. So if it starts from point P, it's reasonable to assume that time is equal to 0 and that the displacement is equal to 0. So therefore, if that's the case, then C is equal to 0, and we've got S is equal to t cubed minus 6t, and we don't have to write plus 0. Now what we're doing here is we are calculating that from the distance in the 3rd second. So we've got to be careful, it's not after 3 seconds, but during the 3rd second. So from the end of the second to the end of the 3rd. So I need to work out the distance after 2 seconds. So if we do that, we get 2 cubed minus 6 times 2, it's 8 minus 12. And 8 minus 12 is negative 4. Then we work out the distance after 3 seconds, so that's 3 cubed is 27. And 27 minus 6 times 3 is 18, and therefore that's equal to 9. Now, interesting, we therefore have got the difference between these two figures, between this amount and that amount, and that's 13. So the distance travelled is 13 seconds overall. By the way, another way of writing this is to do this, and that's quite convenient because it doesn't require C at all. We can use integral notation, and we do from 2 to 3, and we put the velocity statement in there, and we go 3t squared minus 6dx. That's the same as what we did before. So we just integrate this, and we get the same statement, t cubed minus 6t. I don't worry about c, and then we get 3 and 2. So we then substitute 3 into the equation. We already know what that gets, so that's 3 cubed minus 6 times 3, and we subtract what we did when we get 2 into the equation, which is minus 6 times 2. We get 9 minus negative 4, and we still get 13 seconds, and that's another approach to that problem.